Good morning, students. Today we will discuss some remaining parts of the chapter Atomic Structure regarding class 9. Atomic structure. Atomic structure. We will learn once again the atomic mass number, What is atomic mass number? Actually, atomic mass number is the total number of protons and neutrons. For example, atomic number of sodium equals 11. Atomic number of sodium equals 11. The number of neutrons of sodium equal to 12. Therefore, atomic mass number equal to 11 plus 12 equal to 23. It means atomic mass number of an atom is the sum of the numbers of proton and the number of neutrons. Another example can be the atomic number of magnesium equal to 12. The atomic mass number of magnesium equal to 24. Therefore, the number of neutrons equal 24 minus 12 equal to 2. It means when atomic mass number is given and atomic number is given, then we will subtract atomic number from the atomic mass number and we will obtain the number of neutrons. Next, we will know about the isotopes and isobar. What are isotopes and isobar? Actually, isotopes are different atoms of the same element whose atomic mass numbers are same the isotopes are the atoms of the same element whose atomic numbers are same but atomic mass numbers are different. isotopes are the different elements are the different atoms of the same element whose atomic numbers are same, but atomic mass numbers are different. For example, we have three isotopes of the element hydrogen. We have three isotopes for the element hydrogen. Number one is this, known as protium. Number two is this, known as deuterium. And number three is this, known as tritium. It means we have three isotopes of hydrogen: protium, deuterium and tritium. We can see that all the protium, deuterium and tritium have atomic number 1, but they have different atomic mass number. Protium has atomic mass number 1, deuterium has atomic mass number 2 and tritium has atomic mass number 3. We must know that protium is the only atom which has no neutron. प्रोटियम ही एक अकेला ऐसा एटम है जिसका कोई न्यूट्रॉन नहीं होता। इट हैज ओनली वन प्रोटॉन एंड वन इलेक्ट्रॉन बट नो न्यूट्रॉन। Whereas deuterium has one proton, one electron and one neutron. Tritium has one electron, one proton and two neutrons. When protium loses one electron, it becomes protium. When it loses one electron, it becomes proton. When deuterium loses one electron, it is called deuteron. When tritium loses one electron, it is called triton. So the ion of protium is called proton, the ion of deuterium is called deuteron, and the ion of tritium is called triton. We must know that isotopes have different percentage of their presence in the nature. deuterium is very less, but tritium is found in trace amount. Trace amount means it is present, it has been detected somewhere or the other, but its quantity is not as much, so that it has some importance. So tritium is found in trace amount. Similarly, we can take other examples. There are two isotopes of carbon. 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 Number one, this carbon known as carbon 12, and number two, this carbon known as carbon 14. The presence of carbon 14 is very less in the nature. Carbon 14 is used in determining the age of the plant. Carbon 14 is used in determining the age of the plant. Here we can see that sometimes in an atom the number of neutrons is greater than the number of protons. If the number of neutrons in an atom is greater than the number of protons, this atom is called radioactive atom. Such type of elements are called radioactive elements. Radioactive elements are used to determine the age of the plants and other living and non-living bodies. Here we can see that there are two isotopes of carbon. Similarly, there are two isotopes of chlorine. There are two isotopes of chlorine. Isotopes of chlorine atom. Chlorine, this is known as chlorine 35 and this is known as chlorine 37. We can see that there are many elements whose isotopes are present. This can also be called the drawbacks of Dalton's atomic theory, because in his atomic theory Dalton has said that all the atoms of the same element are same in size and mass, but by the discovery of isotopes it has been found that all the atoms of the same element do not have same shape, size and mass. So it is called the drawback Dalton's atomic theory. We also know that some isotopes of an element are in other percentage and some are in other percentage. For example, chlorine 35 in nature is found 75%, whereas chlorine 37 in nature is found only 25%. So while remembering the atomic mass, we usually use or remember the average mass of the element. How to find the average mass of an element? If the percentage of its isotopes are given. What is the average mass? Question is, what is the average mass of chlorine atom if its isotopes chlorine 35 and chlorine 37 are found 75% and 25% respectively in nature. solution will be average mass equal to 35 unit, which is the mass of chlorine, 35 into 75% plus 37 unit, which is the atomic mass of chlorine, 37 into 25%. We will multiply the atomic mass by the percentage of presence. So when we calculate this will be 35 unit into, if we cancel this by 25, this will become 3/4 plus 37 unit plus into 1/4. So when we multiply, it will become 105 unit by 4, and this will be 37 unit by 4. By calculation, it will be 142 unit divided by 4. When we divide it by 4, it will be 35.5 unit. This is the average mass of chlorine atom. So in this manner, we can find the average mass of an atom which is found in isotopic forms. Next one is isobar. Isobar are the different isobars are the atoms of different elements whose atomic mass number are same but atomic numbers are different. Example: R1, whose atomic number is 80 but atomic mass number is 40. Calcium, whose atomic number is 20, atomic mass number is 40. We can see that argon and calcium are the two different atoms of different elements, but both have same atomic mass number but different atomic numbers. So isobars are those atoms of different elements whose atomic mass numbers are same but atomic numbers are different. Next one is isotope. Isotopes are the atoms of different elements which have same number of neutrons. Which has same number of neutrons. For example, sodium and magnesium. Sodium has 11 proton and its atomic mass number is 23. So to find the number of neutrons, we will subtract 11 from 23, will be 12. It means sodium has 12 neutrons. Here we can see also that the proton in magnesium is 12 and atomic number is 24. Thus, by subtracting 12 from 24, we obtain 12, which is the number of neutrons in the magnesium. In this manner, we can see that in both sodium and magnesium, the number of neutrons are 12 each, so they can be called isotopes.